Welcome to our next lesson, 1.8, which is on combinations of functions, which we also just call composite functions. So first, what I'm going to do is I'm going to introduce you to the idea of sum, difference, product, and quotient functions. If we have the sum of, say, two functions, like f plus g of x, we'll just call the two functions f of x and g of x, that's just equal to f of x plus g of x. And then the difference of two functions, for example, maybe we keep using f and g. If we have f minus g of x, we're going to have f of x minus g of x. We'll keep using f and g for product and quotients. So if we have the product of two functions, we're looking at f times g of x. That's just going to be f of x times g of x. And then quotients of two functions, we're looking at f divided by g of x. That's going to equal f of x divided by g of x, with the condition that g of x cannot equal 0, because we can't have our denominator be 0. So let's look at some examples of how we could find these values, the sums of functions, differences, products, and quotients, and then even evaluate them at certain values. So in our first example, let's say f of x is equal to 2x plus 1 and g of x is equal to x squared plus 2x minus 1. We are going to find f plus g of x, and then we're going to find f plus g of 3, so when x is equal to 3. Let's start by just finding f plus g of x. And from our last slide, f plus g of x is equal to f of x plus g of x. And we know what f of x and g of x both are, so let's just replace them in our equation. We will have 2x plus 1 plus x squared plus 2x minus 1. Now we can just combine the two functions. We're going to have an x squared. There's nothing to combine with, just that x squared. We have 2x plus 2x, so we're going to have 4x. And then we have a positive 1 plus a negative 1, which is 0. So f plus g of x is going to be x squared plus 4x. And if we want to find f plus g when x is 3, we're just going to replace x with 3. So we're going to have 3 squared plus 4 times 3. 3 squared is 9, 4 times 3 is 12, and 9 plus 12 is 21. So f plus g when x is equal to 3 equals 21. Let's look at another example. You know what, let's just keep using the f of x and g of x from our last example. So as a reminder, f of x was 2x plus 1, g of x was x squared plus 2x minus 1. This time, let's look for f minus g of x, and then let's look for f minus g when x is equal to 2. So let's start by just finding f minus g of x. And in our first slide we learned f minus g of x is just f of x minus g of x. So let's just replace f of x and g of x with the equations we know they are. So we're going to have 2x plus 1 minus x squared plus 2x minus 1. Now in the addition one, the sum one, we didn't have to worry so much about distributing the plus sign, because that's just silly. In this problem, we do need to distribute this minus, or at the very least keep in mind that we have that minus there. So our next line of work is going to look at, we have a negative x squared. Then if we have 2x minus 2x, that's just 0. And if we have a plus 1, so plus 0x, plus 1 minus negative 1 is like plus 1 again. We're going to end up with a plus 2. So f minus g is going to end up being negative x squared plus 2. Now let's find f minus g when x is 2. We're just going to take our f minus g function and replace x with 2. So we have negative 2 squared plus 2. That's going to give us negative 4 plus 2, which is negative 2. And we're done. Let's look at our next example. This time I want us to find the product of two functions, and I'm going to use two different functions this time. We're going to use f of x is equal to x squared, and g of x is going to equal x minus 3. We're going to find f times g of x, and then we're going to also find f times g when x is equal to 4. So f times g in our first slide we learned is just f of x times g of x. And let's replace those. We know f of x is x squared. We know g of x is x minus 3. If we distribute our x squared to our x minus 3, we're going to get x cubed minus 3x squared, and we just found f times g. Now let's figure out what is that when x is 4. So we're just going to replace x with 4. So 4 cubed minus 3 times 4 squared. Well, 4 cubed, that's 64. Minus 4 squared is 16, so 3 times 16. And 3 times 16 is 48, so we have 64 minus 48. That's going to give us 16. Alright, now let's check out one of these quotient functions. Alright, so we're going to say f of x is going to equal the square root of x, and g of x is going to equal the square root of 4 minus x squared. And instead of evaluating this at a certain value, what I want us to do is I want us to find f over g of x, and I want us to find g over f of x. And then list any values we need to exclude from the domain, which would then just be finding the domain. So we learned on the first page, when we're doing a division or a quotient of two functions, we take the first function. So if we're doing f over g, we take f of x, which we know is the square root of x, and we put it over g of x, which is the square root of 4 minus x squared. Now, to find the domain of this quotient function, all we need to do is know what values of x will make our denominator equal to 0. The only way to do that is take our denominator, square root of 4 minus x squared, and set it equal to 0. So we could square both sides, and we'd get 4 minus x squared equals 0. And then if we add x squared to both sides, we would find that 4, all we're going to figure out then is 4 is equal to x squared, and take the square root of both sides. We'll find that x, to make our denominator equal 0, would be plus or minus 2, but we don't want those values. We can't have our denominator equal 0. So f over g of x is going to be the square root of x over the square root of 4 minus x squared, and x cannot be positive 2 or negative 2. Now let's also find the domain of, or not just the domain, let's find g over f. So in this case, we're going to now take g of x in our numerator, 4 minus x squared, and we're going to put that over the square root of x. If we were to set that equal to 0, we would find that x can't equal 0, and that's the only restriction there. So now we found sums, differences, products, and quotients of two functions. We're going to look at something else real quick. So now we're going to look at the composition of two functions. And we're still going to use f, and we're still going to use g. But compositions of functions look different than products, quotients, sums, and differences. We're looking at f of g of x, which some people call the fog of x, and that's just going to be equal to the f of g of x, which means, or all that really means, is wherever we have x in f of x, we're going to replace it with whatever g of x is. And sometimes we can go the other way. We can have the g of f of x. Some people call that the goff. And that's just g of f of x, meaning wherever x is in g of x, we replace it with the whole expression for f of x. Let's look at an example to get what this really means. So our example, we're going to say we have f of x. This is an example. F of x is going to equal x plus 2. G of x is going to equal 4 minus x squared. We're going to find f of g of x, g of f of x, and then we're going to find the g of f, when x is equal to -2. So let's find the fog, f of g of x. So if we're looking for f of g of x, all we're going to do is wherever we have an x in f of x, or in x plus 2, we're going to replace it with 4 minus x squared. So let's do that. We're going to have 4 minus x squared plus 2. All I did is I took g of x and I put it in to x. Now we can combine any like terms we have. So we're going to have 4 plus 2, that's 6, minus x squared, which we can also write as negative x squared plus 6. I would accept either 6 minus x squared or negative x squared plus 6 for your answer for f of g of x. Now let's find the g of f of x. So what we're going to do is we're going to take f of x, x minus 2, and we're going to plug it in to x in g of x. So we're going to have 4 minus x plus 2 squared. Now we learned in an earlier lesson that x plus 2 squared does have a formula that we can use to expand it. So we're going to have 4 minus x squared plus 4x plus 4. Because that's a perfect square right there. We can go a, which is x in this case, a squared plus 2 times a times b, and b is 2. 2 times a times b would give us the 4x plus b squared. And since b is 2, b squared would be 4. Now let's distribute this minus sign to clean things up. So we're going to have 4 minus x squared minus 4x minus 4, and we can clean it up a little bit more because 4 minus 4 will just get rid of each other. So g of f of x is going to be negative x squared minus 4x. And lastly, we wanted to find the g of f when x is equal to -2. We're going to take that second composite function we just found and replace x with -2. So we're going to have, and I'm going to separate these with lines, we're going to have negative -2 squared minus 4 times -2. Well, -2 squared, that's 4. So we've got -4 minus 4 times -2 is -8. So instead of writing minus -8, I'm going to just change it straight to plus 8. And -4 plus 8 is positive 4. Alright, let's look at how would we find the domain of a composite function in our next example, which we'll do in our next video.